friends, my name is Rekha from Career Launcher. Today we are going to introduce the session Calculus. Okay, let's see today's objective. Today's session objectives are functions and simple graphs representing the different functions. Now, let's say y is dependent on x or uniquely determined by x, then y is a function of x. Let's say x is independent variable. Independent variable means you can choose any value of x, right? And y is dependent variable. So value of y depends only on chosen value of the x. It is represented by y is equal to f of x. This is called as y is equal to f of x. Now, for example, f of x is equal to x plus 2, right? So here y is a function of x in which for every value of x there is a unique value of y, right? So now let's check the graphing. We have the function, as I said, y is equal to f of x is equal to x plus 2. What we need to do is choose different value of x. Let's say x is equal to 0, calculate y. 0 plus 2, it's 2. Let's say put x is equal to 1, get y, it's 3. Let's say x is equal to 2, y is equal to 4. X is equal to 3, y is equal to 5. If you have chosen x is equal to minus 2, you are getting y is equal to 0, right? So every time keep on changing the value of x and get the unique value of y. Now, next step is graph. We'll do one thing. We'll draw two axes. Horizontal is called as x-axis and vertical is taken as y-axis. I'll specifically make certain intervals of x as I have chosen value of x from 0 to 4 or 5 or from 0 to minus 1 or minus 4. Right? So accordingly, I'll make certain intervals like x is equal to 1, 2, 3, 4, 5 up to 8, 9 and this side also minus 1, minus 2, minus 3, minus 4 and so on. Right? If you'll check on y-axis, I have also drawn scales on the y-axis, that is 1, 2, 3, 4 up to 9 and same for negative y-axis, it is from 0, minus 1, minus 2, minus 3, minus 4, minus 5, so on. Right? So now what I need to do is all the time we'll be plotting this value. First point is at x is equal to 0, get y is equal to 0. So first point come here. If you look at the second value, second x is equal to 1, you are getting y is equal to 3. So I'll plot point over here, right? Second point will be here. If I put x is equal to 2, I get y is equal to 4. I'll plot all these points over here and will try to draw a line which is passing through all these points, right? So it means after plotting and after making graph of this, I'll come to know that this function is giving you a straight line graph, right? Look at here, it's domain. Domain is all the possible values of x, right? I have chosen value of x from minus infinity to plus infinity. You can choose any value. So its domain is from minus infinity to plus infinity. Whereas range is all the set of all the possible values of y, right? So obvious x changes from minus infinity to plus infinity. Y is also changes from minus infinity to plus infinity. So range is also minus infinity to plus infinity. We'll come to the second function. Let's take one arbitrary simple function y is equal to 5x square. We are going to repeat the same task again. I'll choose some different value of x, let's say 0, plus minus 1, plus minus 2, plus minus 3 and so on. And every time we'll keep on calculating the respective value of y. Let's say if I say x is equal to 0, you are getting y is equal to also 0. Put x is equal to 1 and get y is equal to 5. Put x is equal to 2 or minus 2, 2 square is 4, 4 into 5 is 20, y is equal to 20, like that. Right? So we'll make this table first, right? Chosen some values of x, we calculated different values of y and I made this table ready. Now what I'm going to do is I'm going to plot this graph, right? We plot the value of y corresponding to the value of x and the graph appears like, look at here. This is the graph of y is equal to 5x square. What I have done here? X-axis. What are the certain marking? I started from 0, plus 1, plus 2, plus 3 up to n values, right? I have chosen till 7 here, right? Left side also you can choose x is equal to minus 1, minus 2, minus 3 up to minus 6, minus 7, whatever, right? Calculate the respective value of y and plot them. First, x is equal to 0, y is equal to 0. Let's say if x is equal to 1, how much is the corresponding value of y? It's 20. Plot this second point. Sorry, first point it's 5, second point it's 20, third point it's 45, fourth point it's at 80. And we'll just check the graph. You'll come to know that this graph is for sure not a straight line, right? So here it's showing some different graph called as parabolic graph. This graph is nothing but parabola. And what is the axis of symmetry? Y is the axis of symmetry for this parabola, right? Concept clear? We'll proceed to the next, domain and range of this. How much is the domain and range of this? Domain is from minus infinity to plus infinity. Why? Because I am allowed to choose any value of x, and value of x will change from minus infinity to plus infinity. Whereas y, again, when we'll change the value of x, it's very obvious that y is also changing accordingly. So when x tends to infinity, y also tends to infinity, right? Therefore, domain is also minus infinity to plus infinity, and range is also from 0 to infinity. Why 0? Because minimum value of y is 0, right? We are not getting negative answer for y because function is x square, right? So whatever value x you'll choose, either positive or negative, always y will be positive. Next function, y is equal to sin x. This is trigonometric function. What you are going to do is, we'll change value of x from 0 to 2 pi, right? Why? Because x is an angle, right? And what are the possible values of x? It's 0, pi by 6, pi by 4, pi by 3, pi by 2, 2 pi by 3, 3 pi by 4, then 6 pi by 6, then it's pi, 7 pi by 6, and so on. Up to where? Up to 2 pi, right? And every time we are going to calculate the value of sin x, right? Sin x, the value of sin x will vary from minus 1, 0 to plus 1, right? So all the possible values of sin x is from minus 1 to plus 1. We'll proceed. Look at the graph of this. This is graph of y is equal to sin x, right? Y, what are the possible values? I said it's plus 1, minus 1. And what value of x you'll select? That must be an angle, right? What are the possible values? 0, pi by 4, pi by 2, 3 pi by 4, pi, so on, up to 2 pi, right? So this is the graph. Done. Now, look at the domain. Domain is changing from minus infinity to plus infinity. Domain stands for possible values of x. You are allowed to change the value of x from minus infinity to plus infinity, but y will change from only minus 1 to plus 1. So therefore range must be minus 1 plus 1. Next, graph of some useful function. Now, whenever you are gonna do many more problems in physics, every time you may get question like, decide the nature of this graph, this versus this, that versus this, right? So that time, looking at the function, you'll be able to identify the nature of the graph. It's like either it's straight line, parabolic, hyperbolic, sine function, cosine function, exponential function, like that, right? So we'll see graph of some more useful functions. Following are the graphs of several functions frequently encountered. Look at the first, it's y is equal to x square. Y is equal to x square, just now I explained it's a parabolic nature. So y is equal to x square, this definitely a parabola, right? If we'll check the axis of symmetry, y must be the axis of symmetry, right? If we'll look at the domain, it changes from minus infinity to plus infinity, whereas range changes from 0 to infinity, right? Why? Because negative value of y is not possible. Now, look at this next function, y square is equal to x. Again, it has parabola, right? Only the changes will be getting axis of symmetry x. Why? We can choose any value of y. As I said, y will change from minus infinity to plus infinity, whereas x will vary from 0 to infinity, right? So again, this graph is a parabolic in nature, but its axis of symmetry must be x-axis, right? Welcome to the next. X, y is equal to c. X and y both are the variables and c is a constant. So when I say product of two variable is constant, so very obvious that they are inversely proportional. If I'll check at this graph, whenever you'll choose small value of x, y goes to maximum possible value, right? You can check at x is equal to 0, I have not defined any value of y, because if I say y is equal to c by x, when x goes to 0, something divided by 0 is undefined, right? So I cannot plot this point over here. But if I'll start increasing the value of x, respective value of y will start coming down, right? And this graph has rectangular hyperbolic nature, or simply hyperbola, right? Now look at the second equation, y is equal to mx plus c. This graph is a straight line graph. Just now I explained about this, y is equal to x plus 5, right? So whenever you have a function in the similar form, then that function will give you a straight line graph, right? So you can check it here. C stands for y-intercept, right? So whatever the value of v, you will have intercept over here, okay? And m is called as slope of the line, right? So if I'll check with this equation, y is equal to x plus 5, slope of this line is 1 and intercept on y-axis must be equal to 5, right? If I'll check the domain, it changes from minus infinity to infinity, and range changes from minus infinity to plus infinity. Now here there are few trigonometric functions. Look at sin x. I just now explained about this sin x, y is equal to sin x function. Similarly, I have drawn over here. Again, you can check value of x, you can change from minus infinity to infinity anything, and respective value of y will change from minus infinity to minus 1 to plus 1. Again, if I'll go for another graph, y is equal to cos x. What is the difference? You will find the again sinusoidal curve over here, but only difference is sin 0 is 0, whereas cos 0 is 1. So that is the only function we are observing in two graphs, right? Again, for second graph also, I'll be selecting different values of theta, and all the time I'll keep on calculating y is equal to cos theta or cos x, right? So and I'll simply plot them on the graph. You'll observe that again domain is from minus infinity to plus infinity, whereas range is from minus 1 to plus 1. Now y is equal to tan x, right? Again, I'll be taking different values of x, and every time I'll plot x versus tan x, right? Graph will be like this. If you'll check this region from 0 to pi by 2, everyone is aware sin 0 0, because tan x is nothing but sin x by cos x, right? So when I'm saying sin x is equal to 0, you get tan x is equal to 0. So from here it starts, right? And as angle increases, sin x increases, whereas cos x decreases, right? And because of that, this value goes like this, right? Now if you'll check towards the 0 to minus 5, again this graph will come like this, okay? This is the graph of y is equal to tan x, or it's a x versus tan x graph. All the domain, all real numbers except odd integer multiples of pi by 2. Why odd integer multiple of pi by 2 is not allowed? Let's say odd integer multiple of pi by 2. Let's say if I'll take 3 pi by 2. 3 pi by 2, it's 1 upon 0. 1 upon 0, it's undefined. So therefore those values of tan x is not possible. So I won't be taking any odd multiple of pi by 2, like pi by 2, 3 pi by 2, 5 pi by 2, it's not allowed, because we are getting undefined value for this. Now y is equal to sin square x. Look at the nature of this function. Again, I said sin x varies in between minus 1 to plus 1. Now what is the function? Y is equal to sin square x. So even though sin x has positive or negative value, square of x is always positive, right? So y is equal to sin square x will vary from 0 to plus 1. Okay, so domain is from minus infinity to plus infinity, whereas range changes from 0 to 1. Next, y is equal to cos square x. Only the difference between two graphs is, for sin square x you are getting 0 at x is equal to 0, whereas cos square x is 1 at x is equal to 0. That's the only difference, otherwise both the graphs look similar. Next. Thank you.